Okay, let's go ahead and get started. This is a very impressive turnout. I know that all of Travis's fellows are here, and many others, a number of faculty. And this is a relatively rare event, but important event for the program, and hopefully will become more frequent over the years, but a PhD Dissertation Defense. I think this is about how many alumni do we have in PhD? About 12, I think, or, okay. So maybe you'll be the lucky 13th. Anyways, probably everyone in the room knows Travis, who has been here for some time, as most PhD students are. So he's been funded by our National Library Medicine training grant, and he is defending his PhD dissertation. So as I explained wrongly like a couple times in the past few months, but in a defense, we do the public presentation, the audience asks questions, the audience is dismissed, the committee stays behind, asks further questions, then the candidate is dismissed and the committee makes their determination of passing the defense. Not necessarily the degree, it still needs to be written up and approved and so forth. Although I think his name will probably appear in the graduation book that's distributed this week. But as the book says, just because you're in the book doesn't mean you have the degree. So, okay, probably more than you want to know. Anyways, Travis came to us from Arkansas. He had a bachelor's degree in computer science from the University of Central Arkansas and also an MBA from the University of Arkansas. He's done a lot of research work since he's been here, and he's going to tell us about it today. While he's been here, he's also worked on some projects at the Portland VA, which I see several VA folks here today, and also did, which others of you in the training grant have done and should consider doing if you have the opportunity, the summer rotation at the Lister Hill Center at NLM. And he's also volunteering as an advocate for the National Alliance on Mental Illness. So he's going to give us a talk on his dissertation work.
I really appreciate everyone showing up today and listening to me present my dissertation. Today, I'm presenting my work in the area of terminology development, text mining, and data mining. Through applications of techniques in these areas, I present an approach to address unstructured free text to the growing problem of data overload. So much of my interest is in building biomedical software applications, specifically to support clinicians and researchers' workflow, and more specifically to support clinical decision applications where acceptance and reliance on the suggestions that the systems provide will be determined, ultimately be determined by their respective accuracy. It's difficult to really predict the future of biomedical software, but in order to achieve this accuracy that's going to be needed, it's safe to assume that it will need to be supported by a robust knowledge base. And these knowledge bases have the opportunity to be the bridge between unstructured data and structured data. So with that, I'm presenting my research in the medical subdomain of PTSD, for which I will provide a quick background and also a background on various terminology, systems, and structures that I explored in this research. Also present a conceptual overview of my project, which consists of the development of the terminology framework and specifically its implementation to support several text mining pipelines for concept recognition. And then using the output from these pipelines, I use that to support a cluster analysis and an association rule mining use case. And then finally close with some opportunities that I've come across to continue this work. So PTSD, or post-traumatic stress disorder, is an anxiety disorder that is triggered by a traumatic event such as military combat, natural disasters, and various types of assaults. The list of potential symptoms is large, but generally includes varying degrees of depression, flashbacks, aggressiveness, and functional impairment. So much of my dissertation, as Bill said, was developed in coordination with the Department of Veteran Affairs healthcare system, which mostly has a population exposed to high incidence of traumatic events. The prevalent studies vary greatly, but for the VA, it's estimated that somewhere around 30% of veterans experience some form of the disorder, compared to about 7 to 8% of the general U.S. population. This high prevalence, along with insufficient screening, as well as symptoms that can show up much later after the trauma has occurred, and other factors contribute to the current healthcare system, both at the VA and within community healthcare settings, not equipped to adequately cope with this disorder. However, one way to assist clinicians and researchers is the development of health information systems, tools, and projects that are still needed. A key resource to support these tools and projects are knowledge bases or vocabularies that are shown here. And they're built in several formats and with varying degrees of coverage, granularity, and processing ability. So simply, a terminology consists of a collection of terms, words, and phrases representing and describing a system of concepts within a domain. So numerous formats, such as those displayed along the slide, they've been used very successfully in current to support a broad range of applications. But as shown along the spectrum, the cost of time and money increase proportionately with the semantic processing capability of each complex structure. So several medical and life science terminologies that are put in use today reside at multiple points along the spectrum. So my terminology fits somewhere here, just past a taxonomy, but short of a full-blown ontology. The PTSD terminology is referred to with its acronym PTSDO throughout this presentation. This is simply a persistent uniform resource locator, simply a naming classification that allows this terminology to be shared, as well as the concepts it contains and added context. So the reason of the naming for PTSDO stands for post-traumatic stress disorder ontology, as future implementations will be to extend this terminology into an ontology for supporting semantic web applications. So a general rule in order to apply an efficient cost-benefit ratio is to only build a structure with enough semantic processing capability in order to support its intended application. So many existing terminologies today have limited coverage and missing information with respect to PTSD concepts and their meaning. The subjective nature of trauma is a barrier to fully understanding the disorder. But a clear opportunity is improving knowledge and extraction of clinical narratives such as this. This narrative is from a case report, and it's obviously rich in needed PTSD terms. So in the pre-PTSD terminology world, existing terminologies did a really good job of recognizing tokens, although there is room for improvement. In this text processed with CTAKE's NLP, natural language processing pipeline, supported by an existing publicly available terminology, the identified treatments are highlighted in blue. The symptoms that are identified are highlighted in green. The red displays false positives, which are pervasive in any terminology with a really broad coverage. Circled in orange shows the domain-related concepts that are missed by the system. So one caveat, it's not just important to be able to extract or identify these concepts, but also to link them to an established terminology standard as well. This need for improved coverage is the motivation behind the research that I'm presenting today, which can be summarized in this conceptual model. So the goal, as stated here, is to identify PTSD symptom and treatment concepts for mining applications. This is achieved through synthesis of terminologies in order to improve the text mining. In the first aim, terminology is collected by manually acquiring concepts from existing resources. There is also a knowledge acquisition that's collected by a semi-automated process. So I hypothesize that the iterative semi-automated knowledge acquisition, this approach will determine when sufficient coverage is met in order to satisfy stakeholder needs. The collection is stored in XML-based format, easily to convertible to support various types of text mining pipelines. In AIM 2, it is validated by coverage accuracy from recall and precision measurements on 2 gold standards that are created. Specifically, the focus of AIM 2 is named entity recognition. This is enhanced by a dictionary-based lookup for concept recognition. In this automated process, any concepts or terms that are not identified because they are missing, they are added to the terminology, and there is a built-in confirmation loop at each task by domain experts. The hypothesis is that the accuracy of the newly developed terminology will be significantly higher than coverage of other evaluated resources with the text processing pipelines. And then finally for AIM 3, the table of extractions that are collected are applied to a data mining use case. The clusters formed are predicted to produce concepts that group uniformly with diagnostic criteria. So a hybrid of methodologies are drawn from requirements gathering and terminology development to implement a structured process while acquiring feedback during construction. So the first method listed here is a popular method commonly referred to as Ontology Development 101. Simply, the steps are determining the scope, enumerating the terms, linking them to existing resources, and defining the hierarchical structure. And these steps fit into the 4-stage engineering model that's shown here and described by the second methodology, methodology. The steps are simply the specification, keeps the system in scope throughout the project, conceptualization, structures the domain knowledge, formalization converts it into computable models, and before implementing the terminology into a computational language that must be maintained and constantly reevaluated. Also, the SKR methods, this is the Semantic Knowledge Representation Group at the National Library of Medicine. They implement a version of this 4-stage engineering for collecting knowledge to support a PubMed visualization application called Semantic Medline. As Bill was saying, I had the opportunity to actually spend 2 rotations working with this group and learning the details of this application. And specifically the steps that they applied to acquire their knowledge, I was able to use those methods directly into my work. So also implemented is a hybrid of techniques for entity identification, which includes both dictionary-based and rule-based. And then finally, because of all the moving parts to the project, agile techniques were implemented for both software development as well as project management. General idea behind agile is to identify problems, address them, and then move on to the next issue. Really important for applying some sort of methodology to the chaos and the many moving pieces to my project and keep it moving forward. So before going on, I think it's important to take a few seconds just to highlight some of the most salient needs that this research was directed to address. So it's known about the large amount of data that is stored in narrative text, especially for mental health patient records, where a majority of the details are completely stored in subjective type text. And this makes the automation of extracting this information particularly challenging, which is why I focused this research from the ground up, where first I focused on building the terminology, and then secondly, building the applications that process its text. So without the proper use of the terminology, it can really become a bottleneck for achieving the accuracy and creating innovation and better quality assessments of these PTSD applications. Also from the stakeholder interviewing and requirements gathering task, it was determined that the priority need from users was concept recognition. This also determined that the scope of the terminology would focus explicitly on the treatments and symptom concepts. So many of the more complex questions that arose from stakeholders, they could only be answered once this accurate concept recognition was achieved. Some of the questions attain to future information extraction, such as evaluating how well symptoms treat specific symptoms, as well as analyzing how PTSD interacts with comorbid disorders, and ultimately for a way to determine patient resiliency. But however, the answers could be in the free text, but concept recognition is a prerequisite. So as I was consulting with the stakeholders and domain experts, I built a prototype from the resources that were listed here. Some of it required a manual linguistic analysis to acquire terms. This prototype framework also provided a visual resource to improve interviews. By guiding user discussions with some of the stakeholders listed here, conversations were much more mutually beneficial. Stakeholders also provided input to the validity of the concepts, whether any were missing, and each was given an opportunity to make any changes to the concepts that were acquired. So next, an element of automation is incorporated. All available electronic documents needed for domain terminology was processed with a text mining pipeline supported by the in-development PTSD terminology framework. So what this figure is showing, when a term is not identified, the PTSDO is researched to determine whether it exists in the terminology. When the identified term is not in the terminology, reputable terminologies and ontologies are referenced before adding it into the terminology. Then the text mining pipeline is reprocessed and it's reevaluated to see if it is identified again. So as the development was iterative, the updated prototype was presented in follow-ups interview sessions with the stakeholders. And this allowed for an ongoing confirmation loop to be established for continuous verification of concepts within the terminology. So to provide a real quick picture of how the terminology is modeled, some of the upper level classes for symptoms are shown here on the left. Symptoms are grouped in coordination with their associated DSM category. I will provide a good background on this DSM and these symptoms a little bit later, as I'm using the DSM as a basis for my cluster analysis. On the right are treatment concepts. These are grouped in categories that are designated by the Joint Veteran Affairs Department of Defense Clinical Management Guidelines for PTSD. So each of these concepts contain more granular concepts that just specifically describe each category. And then each of those contain even more granular terms such as synonyms, abbreviations, and acronyms. So a large percentage of this work for this research were in tasks related to acquiring the terms to build this terminology. And although terminology structure is never really finished because of constant changes, new research, and new findings, a stopping point for this research is based upon reaching reasonable levels of saturation, which is represented here in this saturation curve. So any electronic corpus can be mined with this semi-automated knowledge acquisition technique. For example, PubMed available abstracts using Haynes clinical queries filters was searched with a narrow scope that returned about 2,000 pretty salient abstracts. And this figure is a saturation curve where a total of 363 concepts were obtained from this corpus, and saturation was reached at around 700 documents. So for the last about 75 documents or so, 0 new concepts were obtained. So as the PTSD terminology was being built, I sought to answer whether sufficient concepts could be acquired from available resources. So to investigate this, term overlap and term reuse were explored, as well as concept overlap that's shown in the slide. The top bar displays and identified 356 concepts that were necessary to describe the PTSD symptomatology. Of those, 240 were found in existing resources. So some of those that were found were listed here. 116, such as those listed new concepts here, were created new, meaning they were not found in an existing resource or not found used in the correct context or with the correct meaning. So of the 240 that were found, there's an overlap of about 72.5%. And what this means is that these concepts exist in 2 or more resources, but they're not linked by an external reference. So this highlights a lack of term reuse that needs more attention in the development community. The term reuse can reduce engineering costs and support semantic interoperability among different types of data sets and applications. This overlap was also seen in symptoms at close to 85%. So to close up aim 1, this large amount of overlapping terms with minimal reuse in comparison goes against the purpose of terminology, standardization, interoperability, and sharing. As a part of this research development was to include these external references whenever available. It was found that a great amount of time went into searching for their availability, and this adds considerable amount of time to an already time-consuming process. So this creates an opportunity to streamline this process, and the development community would benefit greatly from this. So the primary goal of aim 2 was to improve named entity recognition, which is a subtask of information extraction and natural language processing. The aim of named entity recognition is to seek and locate and classify elements of text into predefined categories, which for this research was treatment and symptoms. So there are several low-level natural language processing tasks, such as tokenizing, tagging, chunking, normalizing, and parsing. And each of these must be completed before any of these higher-level tasks are completed to include named entity recognition. Named entity recognition is typically evaluated by precision and recall measures, as well as a harmonic mean of the two, which is the F measure. However, these are calculated in the context of natural language processing, which recall and precision are relatively straightforward when tasks are focused at the document level. However, when we're focusing on tokens, such as in this research, boundary errors are very common. So for instance, this group of terms, aggressive outburst as one single concept. Outburst is found, however, aggressive is missed. So in traditional accuracy scoring, this would count as both a false positive and a false negative. And traditionally, finding nothing would have produced a better metric. So to overcome this in named entity recognition evaluation, left boundary, right boundary, and partial matches are calculated for partial credit. For AIM 2 evaluation of symptom and treatment terminology, 2 gold standards were created from the corpora used for automated knowledge acquisition. 10% was set aside for testing, which left 122 PubMed case reports. Also, 82 psychotherapeutic transcripts were annotated for evaluation. For gold standard creation, overall inter-annotator agreement for PubMed case reports was between 80 and 90%. And for the therapy transcripts, it was between 68 and 84%. Also, multiple text mining pipelines and was supported by several terminologies against the gold standards. So for overall analysis, the 2 target concepts of treatment and symptoms, each on the 2 corpora listed here, were analyzed with 20 combinations made up of these 4 text mining pipelines being supported by these 5 terminologies. And so for each combination, what was identified was exact matches, left boundary matches, right boundary, and partial matches. And this created a large amount of data points that are gathered. Some of the categories of false positives are listed down here. With anyone that's done natural language processing work, errors are unavoidable. But what the error analysis exhibits is that a large quantity of the errors were due to the lack of availability in a terminology resource. And this type of error can be corrected with the automated concept identification that I described in the previous slide for knowledge acquisition. So moving from this pre-PTSD terminology world to this wonderful world where it now exists, the focus on improving named entity recognition with the support of the developed terminology from AIM 1, dictionary-based coverage increases the entities that are identified. So in this reprocessed case report here, easy fixes occur when the concepts or terms can be inputted into the terminology and then reprocessed for recognition. So specifically identified concepts from the concept overlap slide that was input are symptoms of self-blame and trust issues, as well as stress inoculation and impact statement that are now found. So some false positives, such as depression here, they cannot be helped. And technically, this is a correct concept in the domain of PTSD. However, this task was directed not to include symptoms that are obviously a part of other mental health disorders. So, and also the pipeline that processed this text was not able to identify the concept of self-mutilating here, even though it is in the terminology resource. Some pipeline deficiencies can't be helped. So likely this one was missed because of the hyphenation and possibly because of the tense ending of the word. In the task of concept recognition, I sought to determine if there's variance between the terminologies in support of the text mining pipelines. Out of the 20 combinations that are evaluated, this is just one combination as an example shown in this graph. It's a fairly good representation of a general pattern across each that is observed. This figure displays variability in the accuracy metrics of identification of treatment concepts in the PubMed corpus explicitly. And accuracy is measured against each of these 5 terminologies. So the first set of bars is from the terminology developed in this research. It generally has a higher F measure than the other terminologies. Generally, its precision is much higher than its recall. Next is PILOTS, which is the PTSD dedicated thesaurus. It generally has really good precision. That's slightly higher than its recall. And this same sort of pattern is mimicked with SNOMED and the National Cancer Institute thesaurus. The last terminology, the UMLS, which is the Unified Medical Language System, this is a system of terminologies maintained by the National Library of Medicine, comprehensive collection of over 100 terminologies, about 1 million concepts, and 4 million names for those concepts. The UMLS by design typically has a better recall than its precision, often due to word sense disambiguation, something that was improved by limiting the types of semantic types that were acquired. So to wrap up AIM 2, without a doubt there's great complexity in clinical entity identification, but what is found is the importance of a domain-specific terminology. With sufficient coverage, there's enough headaches in working with these text mining pipeline and implementing them. Most are not user-friendly, and frequently the output needs to be reformatted for use. Enhancing the terminology, it can improve the output, but it is found there's a definite need for improving text mining pipeline usability. In AIM 3, and to make use of the collection of concepts that were extracted, a cluster analysis use case is implemented. Cluster analysis or clustering is a descriptive analysis where the task is to group a set of objects into the same group where each are more similar in some sense or another to objects that are located in the other clusters. In this example, clustering is performed based upon extracted symptom concepts that are represented here in these word cloud clusters. Extractions from CTAKE's NLP pipeline, supported with the UMLS as a baseline, is compared to extractions that are supported with the PTSD terminology system. And this were implemented to explore whether these concepts could provide insights from the data. The probability of a membership to a cluster in this research is computed by a concept co-occurrence matrix. The corpus that is used is the PubMed abstracts, specifically the search of PTSD case reports, returned just over 1,200 articles with available abstracts. So a little caveat is there's roughly over 100 published clustering algorithms, and several were explored for this research, but the k-means clustering algorithm is implemented where heuristic calculations determine 6 clusters for both the UMLS and the PTSD terminology. So in order to implement the k-means clustering algorithm, one investigation I performed is based upon the DSM shown in those previous slides, and this is the Diagnostic and Statistical Manual of Mental Disorders. It's the standard for psychiatric diagnosis in the United States for all mental health conditions. So there is a bit of controversy with the use of the DSM for determining PTSD. Much of it resides in the quantity of diagnostic criteria that are listed here. So diagnosis requires symptoms from each of these categories. The first is a stressor. Secondly, intrusion or a re-experiencing symptom. Avoidance symptoms. It requires 2 symptoms from negative cognitions. 2 symptoms from arousal category, as well as a functional impairment. And the color white in this research is color-coded for concepts that were identified in the text mining pipeline that did not pertain to PTSD or fit into a DSM criteria. Also, much of the controversy stems from the large number of symptoms that fall within each of these categories, making this disorder overlap with symptoms of several other mental health disorders. So, based upon the extractions from the case report corpus, I explored the uniformity of the DSM clustering for PTSD. Since the reports are of assumed patients diagnosed with the disorder, and cluster membership is based upon co-occurrence at the document level, I would expect each cluster to recapitulate from symptoms from each of these the DSM categories. So for explanation purposes, I represent each of the concept co-occurrence makeup by percentage in the pie charts. On the first row here is clustering based upon the UMLS. The next row is clustering from the newly developed terminology system. So what is noticeable is the clusters on the bottom include concept co-occurrences that draw much more uniformly from the DSM, where those on the top are much more distinct. The UMLS on the top row also extracts many concepts that do not pertain to PTSD and displayed here in white. So just to re-emphasize the symptom makeup of the clustering, such as in cluster 3 here, where membership is determined by the co-occurrence matrix. In this heat map of symptoms listed here, each have varying degrees of co-occurrence with one another and a calculated probability or likelihood of occurring in the cluster of concepts. So for example, the concept of trauma trigger, which comes from the DSM category of stressor, and the concept of fear from negative alterations in cognitions and mood. These occur with one another much more frequently in these case reports than the other symptoms, and thus are calculated to be members of the same cluster. So just to go review this slide one more time, the pattern of concepts with the domain-specific ontology or terminology replicated the DSM fairly well. Now, it's important to point out that this analysis doesn't say that one supportive terminology is better than the other, just that they're different. One could choose a different terminology depending on what they were investigating. They could also vary the number of clusters to calculate. So this highlights one of the shortcomings of clustering analysis and possibly the DSM as a whole, because clusters will always group together regardless if there's any meaningful insight into a particular investigation. It's merely a tool for exploration, not really necessarily for an explicit explanation. And this leads me to the last data mining technique, which is association rule mining. This is a method for discovering interesting relations between data points. The idea comes from market basket analysis used to identify customers that buy which products they buy together. The aim is primarily focused on frequent co-occurring associations among a collection of terms. It's a fairly straightforward, simple data mining technique that takes on sort of the pseudocode structure of if X, then Y. But it's powerful in its respect to potentially leading to interesting discoveries, where an item or items on the left will correspond to an item on the right. So in every introduction of association rule mining, you'll find the beer and diapers association as an example. The story goes, people that go to the store to buy milk and diapers often tend to buy beer at the same time. Association rules can support the finding of patterns across symptoms as well, or symptom co-occurrences, which is done in my research. But this is made possible from the support of the terminology that's developed as well in AIM 1, as well improvements to named entity recognition that was performed in AIM 2. I explored several use cases with various symptom groupings to identify correspondence among symptoms. So this association role mining is implemented to explore whether relationships between symptoms, concepts extracted from the same corpus, to which the previous clustering analysis was applied, could provide insights for generating novel hypotheses. So to extend this use case further, I explored associations that were generated by UMLS support. What is shown in this Venn diagram is that among these two terminologies, some associations generated were the same, as well as they generated associations that were completely different. So in this table is a few examples of associations that were found by both. Symptoms on the left-hand side correspond to symptom on the right-hand side. There is some difference in lift calculations where lift is a calculation of importance determined by a frequency threshold and a confidence probability. One thing to note, the overall count of associations produced by UMLS was much larger than the newly developed terminology. However, many of the metrics were much higher with the PTSD terminology. Rules 2 and 3 here are interesting as they both include less common symptoms that correspond to the DSM stressor criteria. This is interesting because stressors can really trigger the disorder and set in motion the effects of the disorder. So finding all symptoms that can point to it can potentially lead to early identification of patients that are exposed to it. So finally, to demonstrate a useful example, I've gone through all this work to build the terminology. I've attained really good metrics from implementing it in a pipeline, and now I've got hundreds of associations between symptom concepts. At the beginning of the talk, I expressed interest in developing applications to support clinical researchers and clinicians. I also pointed out several deficiencies in the screening process. There is potential in developing clinical monitoring applications where one or two symptoms could identify candidate patients that need to be screened more thoroughly with a checklist. So using minimal number of symptoms can potentially create this sort of clinical alert rather than relying 6 or 7 from the diagnostic criteria or an extensive checklist. And this could improve clinical workflow with this sort of automated process. So using a variant of Swanson's open discovery where literature-based discovery can identify A to B relationships and B to C relationships to explore whether associations can be acquired from the A to C relationships. And these are often less than obvious or well known. And these A to C relationships have been used in several industries for exploring new discoveries and generating ideas. Diane, I need to wrap it up pretty soon. Is that right? I can't see the clock back there. Okay. So while exploring the associations that I collected, I noticed that many of the associations gathered where dissociative concepts explored corresponded to these DSM stressor concepts and with good metrics. And this is heavily supported by the literature where dissociative concepts are used to create risk prediction models. Also noticeable is the many symptoms from the DSM criteria of avoidance that have strong correspondence to these same dissociative concepts. And these avoidance concepts also had some of the best recall and precision metrics in the text mining implementations. So after lowering the threshold and rerunning the algorithm, it's found that these avoidance symptoms do in fact correspond to the stressors, which could be helpful in this sort of clinical event monitoring to identify the candidate patients for more in-depth screening. So when I first began to collect these associations, and with all the criticism of the DSM, the diagnostic criteria, my mind went immediately, well, which one is the most important? And while in this research I came nowhere even close to answering this question, I did find that many interesting associations came from the avoidance symptom clustering. And while browsing these acquired associations, they were not only interesting themselves, but in the fact that they came from PubMed abstracts. And I could only imagine implementing this sort of technique on a rich document corpus such as mental health progress notes. So again, while this is just another tool for exploration, it does provide potential hypothesis that should be investigated with a more scientific study. So hopefully these few examples highlight the importance of expanding terminology research toward developing reliable biomedical applications. There are opportunities to enhance engineering of interoperable methods to acquire this information from any electronic or web available resource. The growing rate of information requires these automated techniques to allow researchers and clinicians to keep pace. The development of these domain-specific terminologies, implementation of text mining pipelines, and pattern identification with the data mining algorithms, they provide opportunities to address this growing information overload. And while this work of developing terminology is time-consuming, it does provide accurate concept recognition and automated annotation. This automation can also provide the annotation component for supervised training of more complex text and data mining algorithms. Also of note, the PTSD terminology, it's built with a top-level ontology characteristics to support future enhancements toward the PTSD ontology. With this ontology, what is hoped is also can be developed is actionable knowledge that can be acquired through semantically annotated and corporate linked to source terminologies. Something that will be important enhancements for processing capabilities to support clinical decision support applications. So in closing, we as a healthcare community have been dealing with this disorder for a really long time and with relatively minimal success. It's my hope that novel approaches such as this, like making use of the growing domain narrative text and applying outside of the box type approaches, that we can acquire proficiencies to acquire this knowledge and garner meaning from it and in a way to positively impact this disorder. With that, I'd like to thank each and every one of my committee members, as well as DMICE, students, faculty, and staff. Also the ontology development group here at the at OHSU, as well as the semantic knowledge representation group at the National Library of Medicine. I'd like to give a good thanks to the Department of Veteran Affairs Healthcare System with all their support. And lastly, my training grant that was made possible by the National Library of Medicine. Thank you. Need to remind about touching the...
Yeah, for those who ask questions, please hold down the mic. Nice presentation. Back in your first aim, when you identified all that new terminology that was not present in any of the existing, did you do any analysis on what type of terms those were? I would imagine, I mean, you showed a few examples, but that a lot of the biomedical terminologies are kind of disease-oriented and common symptom-oriented. But so first, did you look? Actually, I think it's more later on in the talk. But just the ones that you had, all the missing ones you had defined.
Okay.
So the questions are: did you look at the that slide, the new concepts? Any generalizations you can make about the concepts that you found, and is it possible that they mapped into either broader concepts or slightly different concepps?
So yes, absolutely. So how this research came about was through my NLM training rotation and my project to enhance the UMLS in support of their application. And so, in fact, a lot of the concepts do exist, but like you're saying, they're more oriented toward diseases. And they don't meet the context of PTSD definitions. Many of those exist, but what is found is the large number of concepts that are not available. So a common, as my goal is to identify all concepts related to PTSD. Much of the building of the process was developed from annotations that were performed in an annotation project at the Department of Veteran Affairs. And what is often seen is, especially in clinical text, providers will type out exactly what a patient says. So, for instance, of course, a term like hallucination exists in terminology. However, patients will say things like seeing things that aren't there. And so it's my goal that this sort of text can link back to the concept of hallucination. So this sort of information can be shared among other applications. And specifically, as a lot of new developments in specifically the area of treatments that come about, a common example was, I guess, what was it? A lot of new therapies are created that do not exist at all, or are, frankly, some of them are illegal now. Some are, so they're not really defined as a good treatment, but yet. And also just simple things like mindfulness. That is easily captured in a lot of terminologies as a concept of something else. However, mindfulness is important treatment in the area of post-traumatic stress disorder. Yes, please.
You have a question from the Twitter room.
Okay.
Do you see potential for these methods to better define and identify patients with the PTSD dissociative subtype?
Yes, hopefully. And this is where it has to start. This is a really important question because it kind of gets to the heart of what I ultimately see something like this doing. As I was talking about the DSM, there is a great amount of overlap between other symptoms. And commonly in PTSD patients, they are comorbid with other disorders that share these same symptoms. However, treatments are developed specifically to impact these post-traumatic stress disorder symptoms. So in the long term, we do need to be able to identify all concepts and differentiate those that occur from other disorders, such as depression and substance abuse. Yes, sir.
All right, so I'm trying to, thanks for your talk, by the way. Really glad there are strides being made in this area. I'm wondering about the claims about a terminology being helpful in named entity recognition versus it being helpful in evaluating these kinds, or helping serve as sort of a gold standard for finding those things.
Mm-hmm.
So did you tease, I think the evaluation used the PTSDO, is that right? For the evaluation of NER, used that?
Correct.
Right. Did you try using so did you try using alternative types of ontologies or sort of unsupervised methods for coming up with name entity recognition terms other than PTSDO, so that we can tell whether it was just that PTSDO was the right thing to be looking for, or if it was actually that using it in looking for the thing helped. Do you know what I'm trying to say?
I think so. So there's definitely the list of existing terminologies out there is large in several different types of structures that I had represented in one of the slides. So a lot of how the PTSDO was developed, it acquired concepts from those existing resources. However, unless there's an annotation in these existing resources that says this is a PTSD concept, it's going to have trouble recognizing that as explicitly the PTSD concept. And as you're asking about unsupervised technique, in a sense, this is really unsupervised, other than being supported by the terminology. In the long run, looking at other automated techniques, this would provide the supervised training of supporting these more complex evaluations. So, for instance, running this text mining pipeline supported with this PTSDO or any other domain-specific terminology, it could annotate the corpus in order to train these unsupervised based machine learning type algorithms. I think that's what you're kind of asking. Is that sort of?
Yeah. So I'm saying, is PTSDO primarily helpful for providing good annotations or providing good systems?
So, yes. So that sort of gets into the little bit of debate about developing, of this focus, devoting so much time and energy of focusing on the terminology. Because, yes, a lot of this sort of entity identification can be developed with other types of tools, with other types of machine learning algorithms, and wouldn't require this advanced terminology and could make use of those existing terminologies. However, my argument in favor of this is to, rather than putting a lot of this metadata in the code as comments, a lot of this can be stored within the terminology itself. Something that will be really important as this terminology is able to evolve, as PTSD is better understood and new treatments come available. So ultimately, I see a combination of both. If we're going to achieve the necessary accuracy that's going to allow clinicians to make decisions based upon these sort of tools, acquiring information from narrative text, I think it's going to require both. Developing these very advanced, well-covered terminologies, but also focusing on the supervised, unsupervised type of learning, machine learning algorithms. Nathan?
Have you observed any concepts you thought were imprecise, vague, or overly broad? And is there any thought given to removing or modifying these concepts?
So specifically, concepts that need to be acquired or concepts that were acquired from one of the systems?
Concepts that were acquired but might not be as useful.
Yeah, definitely. So there's, again, developing the terminology depending on your intended use case. Are you wanting a higher sensitivity or specificity? My goal is to build the all-inclusive, the capture of terms. So yes, there are a lot of words, depending on the corpus that you're looking at. I mean, of course, this sort of work is a lot easier on medical literature, published literature. The terms are more defined and less vague, a lot of higher level concepts. However, it's tricky when you start looking at the patient records, like the examples that I gave. A lot more abbreviations, a lot more vagueness in the terms that are used in the clinical text. And also, one thing that I didn't cover, a potential future application or source of more terminology is on web forums. Acquiring those, because the extreme of the vagueness of concepts they use there is very great. All right.
Okay.
Thank you.